Find the inverse of the function shown. Here we have f of x equals 2 times the square root of x plus 4. So what we're going to do is we're going to write it as y equals 2 square roots of x plus 4. Switch the x and the y and then solve for y again. So the x goes here and the y goes here. So first thing I'm going to do is divide by 2. X divided by 2 equals the square root of y plus 4. And I'm going to square both sides. So it's going to be x squared divided by 4 equals y plus 4. And then finally subtract 4 from both sides. It's going to be x squared divided by 4 minus 4 equals y. So what I can say is f inverse of x equals x squared divided by 4 minus 4. Now how about the domain? Well, for the original function, we had a domain of -4 to infinity, because anything below -4 gives you a negative inside the square root. Well, the easiest way to think about this is in terms of inputs and outputs. So if you have a -4 for x here, that would be -4 plus 4, which is 0. So really the coordinate would be -4, 0. And remember, with an inverse function, you switch the x and the y. So 0, -4. So 0 is going to be your least input. So your domain over here is going to be 0, infinity. What I'd like to do is show you on the graphing calculator as well. So we're going to have 2 square root of x plus 4. And then for y2, we're going to have the inverse, which is x squared divided by 4, then minus 4. So my zoom's off a little bit. I'm going to go back to standard zoom. So I'm going to do a zoom 6. There's the f of x. There's the inverse function. You know, that looks kind of cool, but it's not really showing the true inverse. So I'm going to do a zoom square, which is 5. Okay, now you can see the true reflection. And I'm going to just graph one more function here, y equals x, because that's the line of reflection here. There you go. So now you can see how the square root function in the blue and the quadratic function in the red are inverses, but it's only for the parabola right here. So from the 0 on, it's a reflection. This other part is not part of the inverse function. So you have to cut it right here, and that's at an input of 0. So that's why I said the domain is the interval from 0 to positive infinity, and it's closed at 0. It means it includes 0. So this is another good example of why you need to restrict the domain when you're doing inverses. So here you go. There's the inverse function and also the domain of the inverse.